Welcome to section 5.5. We are going to look at the properties of logarithms this time. So, some of our learning objectives are work with the properties of logarithms, write a logarithmic expression as a sum or difference of logarithms, write a logarithmic expression as a single logarithm, evaluate logarithms whose base is neither 10 nor e, and graph a logarithmic function whose base is neither 10 nor e. So basically we're going to be looking at these logarithmic properties, rewrite expressions that have logs in them, and then take a look at a whole bunch of logs that are not our common log with base 10 or our natural log with base e. So let's jump in. Here we have our logarithmic properties. We'll just go through it, and this is a handy little table. There's also some of the properties throughout the section of the book. Here we have our product rule, where if we have a product inside of a log, we can rewrite that as the log of the first value plus the log of the second value. Our quotient rule is very similar but deals with division. So if we have a quotient happening inside of our log, then we can rewrite that as the numerator minus the denominator. Our power rule, if we have the log and our value has a power, it's raised to an exponent of some sort, we can rewrite that as our exponent in front of our log. And then our change of base, this one is pretty important. We're going to be using it a lot. It helps us basically if we're working in a log with a base, maybe we can't graph it, we can't picture it, we might not be able to calculate with it. We can rewrite with a base that we want, whatever base we want, we can put it in a different base. Most commonly, we will be rewriting things to change their base to base 10 because that's easier for us. Most calculators work in base 10, so it's a lot easier for us to calculate using it. But especially with graphing, we want to see kind of what is happening on it. So the change of base formula takes a log of some base and we can rewrite it with the log with the base of what we want, and it's the value that's inside the log divided by the log of whatever that base was that we were working in. So now you can see that we have turned it into logs working with a different base. Most commonly, like I said before, we're trying to turn it into base 10 because that's a lot easier for us to put in our calculator and kind of get a value of where it is. The change of base formula is going to be essential, so I would highly recommend memorizing that one. And then we have the equality rule, where if we have log of one value equals the log of another value, notice that our bases are the same here, we're talking in the same base. If these are equal, then that must mean that the values themselves are also equal. Let's take a look at our first objective, work with the properties of logarithms. So we'll just jump right into an example to kind of apply these properties. Given natural log of 2 is represented with A, natural log of 3 is B, and natural log of 5 is C, use our properties of logarithms to write in terms of A, B, and C. We should have and C. We're writing in all terms, we're going to rewrite these things in terms of A's, B's, and C's, no more numbers. Kind of generalizing it here. So the first one is the natural log of 6 over 5. And let's just start by, I see a quotient, so I'm just going to go right back up here and look at my quotient rule. And the quotient rule tells me I can rewrite it as the log of my numerator minus the log of my denominator. So that's exactly what I'm going to do here. I'm just going to rewrite natural log of 6 over 5 as the natural log of 6 minus the natural log of 5. So I was able to use my properties right away. Now, remember, it gave us that the natural log of 2 is A, the natural log of 3 is B, and the natural log of 5 is C. What we've done here is we have a natural log of 5, so that is something that we can rewrite, but we don't have anything for 6, so we're going to have to do a little bit more rewriting here. So we can rewrite 6 in terms of 2's, 3's, and 5's, right? We can rewrite that as the natural log of 2 times 3. And I'm going to go back up to my properties and use the product rule this time, because the product rule lets me rewrite a log that has a product in it with the log of the first value plus the log of the second value. So that's what I'm going to do with my 2 times 3 is use my product property, natural log of 2 plus natural log of 3 minus natural log of 5. That guy didn't change. And now I'm in 2's, 3's, and 5's, which is exactly what we wanted. So natural log of 2 represents A, plus natural log of 3 represents B, minus natural log of 5 represents C. And now we've rewritten it in A's, B's, and C's. Let's do it again. Natural log of the cube root of 25. The first thing I want to do is I want to rewrite this cube root as an exponent. So we're going to apply our exponent rules. If you need to review those, please do so. So whenever I take a cube root, that's the same thing as putting it up to a 1/3 power. So I have the natural log of 25 raised to a 1/3 power. And I can rewrite that as, I want it in terms of 2's, 3's, and 5's. And I have a 25 right now. So what I'm going to do is I'm going to rewrite that 25 in terms of 5's. So I'm going to have 5 squared still raised to that 1/3. So all I did was rewrite 25 as 5 squared. It's still raised to the 1/3 power and it's still inside my natural log. But all I did was rewrite it because I know that 5 times 5 is 25. So remember, again, exponent rules. We have a power, that's not it. We have a power raised to a power. Pow, pow, multiply now. So natural log of 5 raised to a 2/3 power. And now I can use the power rule from above. Whenever we have an exponent raised to a power, we can rewrite that as the power multiplied times the log. So let's pull that 2/3 out front. 2/3 natural log of 5, and natural log of 5 is represented with a C. So 2/3 C. All right, we have one more, natural log of 24. So stop and think a minute. If you need a pause right now so you can give it a try, go ahead. But natural log of 24, I need to write it in terms of 2's, 3's, and 5's. So maybe give this one a try before you move on, and I'm going to work through it. So we've got natural log of 24. If I want it in 2's, 3's, and 5's, I know that I can put it in, get it closer to that by using a 3. I know that 8 times 3 is 24, right? And I also know that I can write 8 in 2's, right? In terms of 2's. So I have natural log 8 is represented by 2 cubed times 3, because 8 times 3 is still 24. And using my product rule, I can rewrite this as the natural log of 2 cubed plus the natural log of 3. And then let's use the power rule on that first one and put our 3 out front of our natural log of 2 plus natural log of 3. And now I think we're ready. We're in terms of 2's and 3's. So 3, natural log of 2 is represented by an A, and natural log of 3 is represented by a B. And there we go, we've got it. Awesome job. Okay, moving right along, we want to rewrite expressions into a sum or difference. So here we're going to be using our same properties, but now we're going to take one giant monster looking logarithm and break it up and spread it out. So first we have the natural log of 2x times square root of x squared plus 1 divided by x plus 3. So right now it looks pretty overwhelming, but we can use our properties to rewrite it and work on it one piece at a time. So let's jump in, let's do it. First, I know I have this big division, so let's use our quotient rule. And our quotient rule says we can rewrite a log of a quotient as the log of the numerator minus the log of the denominator. So we'll write natural log of our numerator, 2x times the square root of x squared plus 1 minus the log of our denominator, so natural log of x plus 3. Good so far. Now, the first natural log here is a lot of numbers being multiplied by each other. So let's use our product rule. I'm going to do 2 at once. Natural log, I have 2 times x times the square root. So natural log of 2 plus the natural log of x plus the natural log of the square root of x squared plus 1 minus that last one, natural log of x plus 3. Okay. Now, let's focus on that square root. Remember, our exponent properties tell us that a square root can be turned into an exponent. So we have natural log of 2 plus the natural log of x plus the natural log of x squared plus 1, and a square root raises it to 1/2 power, minus the last guy, natural log of x plus 3. And then we can use our power rule. Now that we have a power, we can use our power rule. So we have the natural log of 2 plus the natural log of x plus, we're going to rewrite that with our power out front, natural log of x squared plus 1 minus the natural log of x plus 3. And there we did. We've expanded it. It's what some other text might refer to this as, is expanding it. Let's do another. Same thing. We're just going to work one process at a time using those properties to turn this into a bunch of sums and differences. Log base 2 of x squared minus 4 divided by x plus 5. Again, I see that division, so the first thing it makes me want to do is write the log of the numerator minus the log of the denominator. So I have log, I don't know why I wrote it that way, I'm sorry. Log base 2 of x squared minus 4 minus log base 2 of x plus 5. Okay. Now, you might think we can't do anything else. Our properties don't say anything about adding and subtracting inside of a log. And if we weren't dealing with this guy right here, x squared minus 4, I'd agree with you. But because I know that x squared minus 4 can be rewritten, there's a few more steps we have. So think about this. X squared minus 4 we can rewrite as x plus 2 times x minus 2. So we're referring back to those factoring days of algebra. Then we have log base 2 of x plus 5. And now I have a quantity times another quantity. I have a product going on, so I can use my product rule and break that into 2 logs. Log base 2 of x plus 2 plus log base 2 of x minus 2 minus log base 2 of x plus 5. And now we have finished. We've expanded it all the way out. One thing I do want you to notice is that it started with a log base 2, and we've carried that through all of our logs all the way until our final answer. It started in a log base 2, so that's where we're working. We're working in log base 2. Awesome. Now, can we go the other way? Can we take one that's all spread out, that's all expanded, that's all sums and differences, and rewrite it as one single logarithm? Well, let's try it. We're going to continue to use our log properties to write an expression as a single logarithm, our third objective for today. So write each logarithm as a single logarithm. Here we have the natural log of x squared minus 25 minus 4 natural log x plus 5. Well, let's start by making them both single natural logs. What I mean is, I don't want this one to have 4 natural log. I just want them both to be 1 natural log. So here we have natural log of x squared minus 25 minus, and then if I use that power rule and I have the number out front of my log, I can rewrite it. So we're going backwards. I can rewrite it as what's inside my log raised to that number as a power. So we have x plus 5 inside of there, and I'm raising it to the 4th power. And it's still in the natural log. We've just used our power rule to put that number that's multiplying our log back up in its exponent place. Okay, now that they're both just a singular natural log, we can rewrite that as, what do we do when we are subtracting 2 logs? Well, we can rewrite that using our quotient rule. When we have one quantity minus another, we can rewrite those as the numerator and the denominator. So I'm going to have natural log of x squared minus 25 over x plus 5 to the 4th power. That's inside my natural log. Now, I'm going to do that same trick that we did in the last example and recall that knowledge I have about factoring, because I know I can rewrite x minus 25, or x squared minus 25, I can rewrite that as x plus 5 x minus 5. And you're probably wondering, like, why would we want it to be written as 1? Why would you be pulling this out and making it longer? Because I'm going to show you here in a second. I have a reason. Now that I have the x plus 5 in the numerator and the denominator, I can cancel. That's not what we want to do. I can cancel one of the numerators and one of the denominators. I can cancel those out because an x plus 5 divided by itself, anything divided by itself is 1. So we can reduce this almost. We're reducing our fraction. So now we've got, on the top, an x minus 5, and on the bottom, x plus 5 to the third. And that's still inside of our natural log. And now we are done. Let's do another one. We have 2 log of 3x cubed minus 1/3 log of x cubed minus 2. So again, I kind of want these things to just be a singular log. I don't want to have 2 log. I don't want to have 1/3 log. I just want 1 log. So what I'm going to do is I'm going to use my power rule and put those powers back up in their places. So we're going to have log of 3x cubed raised to a second power squared, I guess, minus log of x cubed minus 2 to a 1/3 power. Nope. And that's in the log. So now that I've put the powers back in their spots with our power rule, I have log minus log. And when I have log minus log, that lets me put it into our quotient rule, right? So right before I do this, I'm gonna simplify a little bit. Here we have a power 3 to the 1 power, x to the 3rd power, all raised to the 2nd power. Our exponent rules tell us that's a pow multiply now. And then over here, we have to the 1/3 power, and that tells me I'm going to be taking the cube root. So let me rewrite these before we do our quotient rule. Log 3 squared is 9, and x cubed squared is x to the 6th, minus log of, and we're taking the cube root of x cubed minus 2. Okay, so I just rewrote them using my exponent properties, and now I am going to use my quotient rule. I have 1 log minus another log, so I can rewrite those as numerator and denominator. 9 log of 9x to the 6th power over the cube root of x cubed minus 2. This is all inside of this log. And that is as far as we can go. We've brought it all the way down to 1 log. And that was our goal, was to write it as 1 log. Okay, now we are going to refer back to that change of base for our 4th objective, evaluating logarithms whose base is neither 10 nor e, and this is where that really important change of base formula comes in handy. So let's say we want to know what is the value of these logs, these logs that don't have the base of 10 or natural log. I can't just throw it into my calculator and see it because I don't know how to put log base 6. Maybe, okay, let me back up. Some calculators are very fancy and you can put the base 6 in there, but Some of them are not as fancy. Maybe you have not as a fancy one. And it's okay. That's why we have our change of base formula. It's very helpful for these situations in particular. So what we do is we have log base A of x. So we put log of x as our numerator and log of that base as our denominator. And so let's try it. Log base 6 of 120, we would rewrite as log of 120 over log 6. And this we can put in our calculator. So why don't we take a look at our calculator here, and we can write there it is, log of 120 divided by there he is, log of 6. And we can see it gives us about 2.672, we can say. So this is a value of 2.672. And I put the squiggly equals because it's approximate. This number goes on forever. We're going to put the squiggly equals because it's not directly equal, it's our approximation. Let's do it again. Log base pi of 5.3. Let's rewrite it using our change of base formula. We'll have log 5.3 over log of pi. Now, notice that I, just out of habit, am turning all of these logs into base 10. And that's what the calculator is working out of, is base 10. So we have log of 5.3 over the log of pi. I'll show you that one. Log 5.3 over log of pi, and that gives us about 1.457. So this is about 1.457. So now we have these approximation, we have these values for these logs that we couldn't figure out before, but now that we have our change of base formula, we can get an approximate value. And it helps us do more than just that. It's very important, and here's another reason why. Let's say we want to graph the log base 2 of x. So we're graphing something, it's not base 10 and it's not base e, it's base 2. Well, I need to be able to put this into my graphing utility, my graphing calculator. So I'm going to use my change of base formula. So this is going to be log of x over log of 2. And let's see what this now looks like on a graph where we couldn't have plugged that in before, and now that we can. So I will show you this one now. We have log using our change of base formula, log of x over log of 2. And this is going to show us the graph of log base 2. So this is our function here, log base 2 of x. And it is slightly different than log of x. It's in a different base. And that is how we graph our log functions whose base is not 10, not e, not these common bases that we are used to. We just use our change of base formula and we're able to graph them just the same. One important note that I do want to point out is we saw this a lot in some of our problems where inside of our log we had two things adding together or subtracting together. And we are not going to be splitting that up, log plus the other log. These things are not equivalent. And I just want to bring that point home with an example. So here's an example that I want to show you these. We cannot put, if I have log of m plus n, it's not the same as log of m plus log of n. And I'm going to show you right now. So if I have log base 2 of 8, that is not going to be equal to log base 2 of 4 plus log base 2 of 4. So if we figure out what is log base 2 of 8, well, we can use our change of base formula just like we did before. So we have log eight over log 2, and log base 2 of 8 is 3, so this side equals 3, and I'm showing that it's not equal to log base 2 of 4 plus log base 2 of 4. So what is log base 2 of 4? Well, that's going to be log 4 over log 2. And log base 2 of 4 is 2. So this is not equal to 2 plus 2. 3 is not equal to 4. And there we go. So if you get to a point where we have, like this, we could have written it as log base 2 of 4 plus 4. It's not equal to log base 2 of 4 plus log base 2 of 4. And that's just referring back to our properties. Our properties never said we could do anything with a sum or a difference in there, only if there's a product or a quotient. Those are the only properties that we're given. So I hope this helps you. I expect that you will be completing your guided notes for the 5.5 section and completing the homework assignment and discussion questions as well.